in order to simplify radicals, we have to know what those words mean. So, it kind of tells you right here what a radical means. What's a radical? The symbol itself is called a radical symbol. Put that symbol up there on the front page of your notes. And so we need to talk about, well, I'll get there in a minute. I do not teach these steps. I'm going to show you another way to simplify radicals. If you know how to simplify radicals by using these steps, you're perfectly welcome to do that. So let's look at an example. What does it mean, simplify radicals? Well, this is the radical. So what is that simplified? What is the square root of 16? Why is it 4? Because 16 is 4 times 4, and that pair becomes just 1 4. What is this right here called? A square root. Another name for it is a radical. Why is it called a square root? Do you know that? Do you know it has a connection to a square? If I had a square and the area of the square is 16, what would the side of the square be equal to? 4. Did you know that that's what you're finding when you find the square root? If the area is this much, the side is 4. And that's why it's called a square root, is because it's tied to a square that you learned about in geometry. What is the square root of 49? Because if I had a square where the area was 49, the sides of those squares would be 7. Did you know that's what you're finding? When you're finding a square root, you're finding the side of the square. But is there a difficulty with the next example? Can you find the square root of 48? What? How did you find that? What? With the calculator, right? So but was it exactly a 6.9? You rounded that off. And so she found the square root by using the calculator, and I put this little squiggly equal sign. That means it's approximately equal to 6.9, and that is a rounded off answer. Is there any whole number where the area is 48, is there any whole numbers that could represent that side? Because 6 times 6 would be 36, and 7 times 7 would be 49. It skipped over 48. Now, what I need you to know is the terminology that we're using today is somewhat old-fashioned. That is pretty simple. To put the 48 in your calculator and take the square root with your calculator. That's simple to do, right? But the terminology is from a long time ago. That 6.9 is not an easy number to find if you do not have a calculator. I am so old that when I was in high school, we had to find that number without the calculator. And it is a long, tedious, difficult process to find that number without a calculator. So that's not what we mean when we say simplify in math, because the terminology is old-fashioned, like me. That is called approximation. One of my students one year called it decimalizing. Now, that's not a real word, but I keep using it because it's kind of obvious what it means. We are not going to decimalize. We are going to simplify. So, here's how you simplify. Now, I would like you to draw a line across your paper above problem number E. And I would like you to draw a line down the middle of your paper so that you divide your paper into sections, 4 sections for your 4 problems on the front of your page. So I'm going to show you a process for simplifying that's called the birthday cake. And so I want you to write this 48 number down here at the bottom of your part C square. Can you divide by 2? If you can divide by 2 or divide by 3, you can do this. And that's why I like this method, because you always start the same way. You always start by dividing by 2 if you can. How many times does 2 go into 48? And you keep dividing by 2 as long as you possibly can. Will 2 go into 24? Will 2 go into 12? Will 2 go into 6? And will 2 go into 3? The only thing that will go into 3 is 3. 3 goes into 3 one time. And that's how you know you're finished, when you get all the way down to 1. Okay, now, the reason this is called the birthday cake is if you have a little imagination, you can see the layer cake with the birthday candle on the top. You have an imagination? Okay, so now that I have done this, now what? Well, back over here to this example, what does the square root do? It finds pairs. It changes the pair of 4s into just 1 4 because it changes the area into the side. Okay, back over here on my example, that's what I'm looking for. I'm looking for pairs. On the outside, those numbers are all divided away. There's a pair of 2s, and there's another pair of 2s. I'm looking for pairs. The square root changes this pair of 2s into just 1 2. This pair of 2s, but I have some numbers left over that don't have pairs. The numbers that are left over that don't have pairs have to stay under the radical sign. The numbers that come out of the radical sign, these are all multiplied together to get 48. So 2 times 2 is 4. That is the simplified 48. I know it's a lot simpler to you to just put the 48 in the calculator and get 6.9 as your answer. But again, this terminology is old-fashioned. Now, this number right here has not been rounded off. The 6.9 or the 6.92 is a rounded off number. This is an exact answer. Are there sometimes it's important to have exact answers? Is there? Read about in the paper that the scientists at NASA made a little rounding error in their spaceship, their probe totally missed Mars. It was supposed to be going to Mars, and they just made a little bit of error, but it missed it completely. You know, would you want if you had some kind of major surgery, would you want your doctor to kind of just round off and cut in kind of the right place? Or would you want him to be exactly in the right place for your surgery? Not that it would, I doubt he's using square roots to do that, though. Okay, but there are some places where it is important to be exact. What we are doing is getting an exact answer, not a rounded off answer. So, we're going to put our number down here at the bottom, and we always start at the same place if we can, dividing by 2. Can I divide by 2? Then I divide by the next biggest number, 3. You keep the numbers in order so you don't miss anything. Will 3 go into 75? Will 3 go into 25? What's the next biggest number that's going to go into 25? 5 will go into 5. 5 will divide into 5, and you keep going until you get a 1 for your answer. That's how you know that you can stop. And what are you looking for? Pairs. Do you see a pair? I have a pair of 5s, and what's left over? I have a 3 left over and a 1 left over. What's 3 times 1? 3. The pairs go on the outside, the unpairs stay on the inside. Pairs on the outside, unpairs on the inside. Okay, go down here to the bottom. We'll get to that 3 in a minute. We're going to start with the 60. Go down here at the bottom of your page and write down a 60. How many does 2 divide into 60? 2 will go into 30. Will 2 go into 15? If you can't divide by 2, then try dividing by 3. 3 will go into 15. The only thing that will go into 5 is 5. Why do we do this? We're looking for pairs. What pairs do we have? And my unpairs are 3 and 5 and 1. And we also have this 3 that was already out in front. It just comes down and continues to stay out in front. For my final answer, we multiply these numbers together, and you multiply these numbers together. That is the simplified answer, even though it doesn't look very simple, does it? What are we going to do? Going to write the 32 at the bottom. We always start in the same place. If you can divide by 2, you start by dividing by 2. And you keep dividing by 2 as long as you possibly can. That's a lot of 2. And once you divide by 2 all of those times, then what do? There's a pair of 2's. There's another pair of 2's. What's left over is a 2 times a 1. We also, out in front, had the number 5. Multiply 5 times 2 times 2 for the number out in front. 2 times 1 stays under the radical sign. Before we look at these variables, well, if we have some variables, I can't very well write them down and divide by 2. If I'm going to have variables, what I'm going to do is I am going to expand the variable. X squared is equal to x times x. But I'm still looking for the same thing. Pairs. Do you see a pair? How many pairs? So that would be x to the first power. Do we usually write the first power when it's x to the first power? X to the fourth is x times, there's the 4 x's. And I circle the pairs. If I have a variable, I'm going to expand it. and circle the pairs. How many pairs do I have? So that's going to be x squared because there's 2 pairs when I expand it and I circle the x's. X to the 6th power, I'm going to expand that by writing down 6 x's. 1, 2, 3, 4, 5, 6. And then I'm going to find the pairs. How many pairs? If it's x to the 8th power, I write down 8 x's. And then I find the pairs. Circle the pairs. How many pairs? So if you have a variable, you're going to expand the variable and find the pairs. So if I have x to the 3rd power, that's x to the 3rd power, and I'm going to find the pairs. But this time, there's 1 left over. So this makes an x on the outside. This one that doesn't have a pair has to stay on the inside, just like the whole numbers. If it doesn't have a pair, it has to stay in the house. 1, 2, 3, 4, 5. That's what x to the 5th power means. How many pairs? So this would be x has 2 pairs, and what's left over has to stay underneath the radical sign. So, what about the next kind of problem? The next kind of problem has, I'm going to skip those, go to E. The next problem that we're going to do has a number and a variable. Well, I'm going to have to do those separately. The number, I'm going to go down here and write down the 12, and 2 will go into 12, and 2 will go into 6, and 3 will go into 3. That's the number part. And I found the pairs. So this is going to have a pair of 2s. Now I'm going to skip a space here. And a 3 left over. 3 times 1 left over. Now for the x squared. X squared is x times x. There's a pair. So the pair comes on the outside. And that's the order we usually write it in. We put the number, then the variable, then the radical sign. The radical sign always goes at the end. If you have numbers and variables, you figure out the number first. Write the 72 down. How many times does 2 go into 72? And then 2 will go into 36. And 2 will go into 18. 2 doesn't go into 9. So you divide the next biggest number. The next biggest number is 3 will go into 9. And you find pairs. A pair of 3s, a pair of 2s. You have a pair of 3s, a pair of 2s, and I have, I was just about to say that. I have a 6 on the outside. I need to bring down the 6 on the outside also. Now, I have some variables. I have x squared, y to the 3rd power. I have a pair of x's and a pair of y's, and the y that's left over has to stay underneath the radical sign. To clean this up a little bit. I multiply those together. That would be a 36xy. This doesn't look very simplified, but that is called the simplified answer.